sum, here we have given d2y upon dx square plus 5 dy by dx plus 6y is equals to 0. This is the main basic sums. So wherever you will see d by dx, we will replace it by d, and wherever you will see its double derivative, means d square upon dx square is equals to d square, we will replace it by d square. So in this sum, d2y by dx square, so d2y by, we will directly replace d square, means this whole term will be replaced by d square, and this remaining y, this y directly we have written here. Now plus 5 as it is, and now see d by dx, so d by dx we will write directly d, so phi d, we have replaced this by d, and this y as it is, so it is phi dy plus 6y is equal to 0. Okay, then as you can see, this equation will come in the quadratic equation. So y is common in this whole term, so if we taken y common, so d square plus phi d plus 6, so bracket, and this y we have taken common from this is equal to 0. Now to find the roots of this, we will have to equate it with the help 0. So d square plus phi d plus 6 is equal to 0, means nothing we have to do, just this equation is equal to 0. So now in the calci, if you find the roots, you will find d is equals to minus 3 and minus 2, means simply you can write it as m1 is equals to minus 3 and m2 is equals to minus 2. So that example we saw was of case 1. So real factors, real means different real factors we got, means m1, m2, m3, means different types of. So for that formula is CF is equals to c1 e raised to m1x plus c2 e raised to m2x, and then so on. So that formula we have written CF is equals to c1 e raised to m1x plus c2 e raised to m2x. So again we will write final answer, that is CF is equals to c1 e raised to, but m1 we have got now, which is the factor for this quadratic equation. So m1 we will replace by minus 3, so c1 e raised to minus 3x, here m1 is written as minus 3, and plus c2 e raised to minus 2x, means m2 is minus 2, so c2 e raised to minus 2x. Now next, different factors, means again if another quadratic equation will be there. So if we got 2, minus 1 or 4, means different types of numbers, means different factors. So here again for this equation we have to write CF, means complementary function. So complementary function is c1 e raised to m1x plus c2 e raised to m2x, but now we have the values of m1 and m2. So simply we will write c1 e raised to the first factor, means 2x, plus c2 e raised to, now it is minus 1, so just minus 1x also you can write, or minus x also, and plus c3 e raised to 4x, means m3. Now another case, means if we have same roots, means m1 is equals to 2 and m2 is also equal to 2. So for this, so in the case 2, repeated real factors. So in this repeated real factors, we will get m1 is equals to m2, means same numbers like previously in that example we saw 2 and 2, both are m1 is equals to 2 and m2 is also equal to 2. So for that complementary function is c1 plus c2x, this whole bracket, and in multiplication with e raised to m1x. So now we have got both same factors. So for this, a complementary function is equals to c1 plus c2x e raised to m1x. So we will write the answer c1 plus c2x, this term will be as it is, but e raised to m1x we will replace by this 2, means only both are same only, so for that only e raised to m1x, means e raised to 2x. This is second type of case. Also in case 2, we saw the first method, means if we got only two factors, mean m1 is equals to m2, means 2 2 or 3 3 or any other number which are same factors. So for that we saw the formula that complementary function is equals to c1 plus c2x, and in multiplication e raised to m1x. But in case you got three factors, means m1 is equals to m2 is equals to m3, means 2 2 2 or 4 4 4 or 7 7 7, any of the number which are same three times, means three factors we got same. So for that formula will be complementary function c1 plus c2x plus c3x square, and in multiplication with e raised to m1x. So this whole term as it is we want to write, just replace e raised to m1x, means m1 we will write this number, means for example 2 2 2 we got, so e raised to 2x only, and all this will be same. Just in this second method this extra term is added, means c3x square. Now in the third case we have imaginary terms, means suppose we got alpha plus minus beta I, means in these terms we got for example 2 plus minus 3i. So for this complementary function is equal to e raised to alpha x in bracket c1 cos beta x plus c2 sin beta x. It's looking very complement. So another third case we have imaginary terms, means suppose we got 2 plus minus 3i, means in calculus we will get 2 plus 3i and 2 minus 3i, so we can write it as 2 plus minus 3i. So for that means this is the format alpha plus minus beta I. So alpha is always real part and beta is always imaginary. Imaginary means the term which is with the I, and also remember the beta we will always taking positive. So for that complementary function is equal to e raised to alpha x in bracket c1 cos beta x plus c2 sin beta x. So say suppose in calculus you got that minus 2 plus minus 3i. So now here I said beta will be always positive. So for this complementary function cf is equals to e raised to alpha x we saw previously. So e raised to alpha means what? Means minus 2. Alpha is minus 2. So e raised to minus 2x, and in bracket c1 cos beta x. So beta what we have got? It is 3. So c1 cos 3x plus c2 sin 3x, means beta again this 3 only we will write. So this is the sum d2y upon dx square minus 5dy by dx plus 6y is equals to 0. So this equation again we know that already we have seen the basics, that if we got this then we will directly replace it by d square, and this y as it is minus 5 as it is, d by dx we will replace it by d, and then this y as it is plus 6y is equals to 0. Here 6y directly we have written because it is not containing any reciprocal, means not a fraction, means d by dx or d2 by d2x upon. So this is another sum d2y upon dx square minus 5 dy by dx plus 6y is equals to 0. So in the previous sum we have already shown that this whole term we can replace by d square and this y as it is, means properly if you shown that, so d square upon dx square, this whole term we can write as d square, but this y as it is, and minus 5 also as it is, d by dx we can replace it by d, and this y as it is, so it will be minus 5 dy plus 6y is equals to 0. This 6y as it is means written because there is not any term of fraction, means d by dx is not there, d by dx means d square upon dx square term is also not there, means nothing here. So 6y directly we have written as it is equals to 0. So now for finding the quadratic equation we will take the y common from this. So if we taken the y common, so it will only remain d square minus 5d plus 6 is equal to 0, means directly this y don't write it, means directly common and is equal to 0. So for the quadratic equation always there is rule that this whole term is equal to 0. So d square minus 5d plus 6 is equal to 0, means simply y, if we here it is in multiplication and if it go on to division it will be 0. So after this if you put this means in calci, so you will get the roots m1 3 and m2 is equals to 2, or in some calculus you will get first 2 and then you will got 3, that is same only. So for this complementary function c1 e raised to m1x plus c2 e raised to m2x, so c1 e raised to m1 is 3, so 3x plus c2 e raised to 2x.